In this lesson, we're going to look at populations. So remember that organisms need energy, materials, and space, and then their niche is how they get these things or their role in the ecosystem. So now let's think about how life is organized. So a single organism or single individual is called an organism. So this would be like one zebra. A population is a group of the same species. So this would be like a herd of zebra. And then a community is populations that interact. So this would be the population of zebras and wildebeest and elephants and giraffes and lions and so on that make up an ecosystem. Now, ecosystems evolve to where there is a species that occupies every niche. So if there are open niches, then a species will evolve to fill that. And this results in ecosystems moving towards balance. In other words, if every niche is filled, the ecosystem is in balance. And this means that all these species are going to be interacting with each other. And this is called symbiosis. And it also means that all organisms are dependent on each other for survival. Whether it be to get food or to provide some service, all organisms are dependent on each other. And you can see this in a food web. So if you notice, none of these organisms have a arrow only from one other organism. So they are dependent on each other to keep this whole system in balance. Now, as a result of this, they're going to interact in a number of different ways. These are symbiotic relationships. The first of which is mutualism, which means that they both of the organisms benefit. Commensalism means that one benefits and the other is not harmed. We have parasitism, so a parasite, where one benefits and the other is harmed. And then we have predation, where one eats the other. So here's an example of commensalism, where this one fish is kind of hitching a ride on the shark. So the shark isn't getting hurt in any way, but the fish is benefiting. This is obviously predation. This is a tapeworm, so that's an example of parasitism. And this is mutualism, where these ants and aphids are working together. The ants provide protection and the aphids provide food. So they're both getting something out of this deal. This affects populations in a number of ways, but the primary way is it creates a carrying capacity. In other words, how many individuals of a particular species an ecosystem can support. All right, there's only so many deer that a particular forest can support. That would be the carrying capacity. And just like with that example, this is based on resource availability. There's only so much food, there's only so much space, and there's only so much water and other materials. Populations change based on resource availability. So in this first part of a graph, we have what is called exponential growth. So populations, when there are no resource shortages, will grow exponentially. Sometimes this is called a J-shaped curve. And this is because the birth rate is going to be much higher than the death rate. So not very many organisms are dying, but they're having a lot of kids. So this would be exponential growth. Now, as the population starts to reach the carrying capacity, resources are going to start to become limited. There's not going to be as much food. That means that the growth is now going to slow down, and it's going to stabilize along that carrying capacity. And so the birth rate and the death rate are going to be just about equal. And this is called logistic growth. Predation has a major impact on populations because it really helps keep populations stable, both from the predators and for the prey. So, for example, wolves are an apex predator, and they're actually really important in ecosystems in ways that you wouldn't necessarily think about. If you remove the wolves, which happened a lot in U.S. forests, the deer population is then going to dramatically increase because the wolves helped to keep down the deer population. And then the deer, because there's so many of them, they're going to eat all the plants. Now there's no more food, and the deer population will crash because all these deer are going to starve to death. So without the wolves, that population goes through these what are called oscillations, where you get huge population growth and then massive die-offs. What's supposed to happen is, let's say the prey population increases a little bit. As a result of that, the predator population will increase because there's more food. When the predator population increases, they will suppress or reduce the prey population, and then the predator population will go down correspondingly. And so in that way, we will have little changes in population, but it will maintain a relatively stable population number. Now, human population, we keep growing exponentially. We're still on that J-shaped part of the curve, and that's because every time we think we're getting close to the carrying capacity of the Earth, we are able to raise it through technology, being able to grow more food, extracting more resources, these kind of things. So we are continuing to grow exponentially, which is probably going to be a really, really bad thing in the future. This is an example, and most of you should have seen these before. These are what are called population pyramids, and these represent how a human population is growing in a certain country. So when we look at this first one, this is what's called fast growth. So the blue bars at the bottom represent children, and then the kind of maroon bars at the top represent older people. So what this is saying is there's a lot of kids, not a lot of old people. So this is extremely fast growth. Places like Kenya, Nigeria, generally less developed places. And so the birth rate is much, much higher than the death rate. In this next one, there's really very low to really no growth. Places like the US, Canada, Australia, the birth rate and the death rate are relatively equal. So we have basically as many kids being born as we have old people dying. And then finally, we have negative growth. In some countries like Austria, Denmark, Italy, Japan, we actually have a situation in which there are more people dying than being born. And so the population is actually decreasing. And so basically when you look at these, the bigger the base, the faster the growth.